All right. Hi, everyone. So I am the guy with the long name, Maciek. Together with me, I have Tibor, Peter, and Radko, CSIT commuters and contributors. So we'll be presenting the and discussing the new FDIO CSIT performance dashboard on behalf of the CSIT project. So we have few slides. We also have few screens to share, and I think we have some time for discussion afterwards. Hopefully my slides are coming across.
Yes, I can see.
Okay, cool. Thank you, Dave. Let me just clean some stuff. So we quickly cover, VPP and CSIT core projects and how do they intersect. We're then gonna dive into the CSIT dashboard, CSIT FDIO, where Peter is gonna cover infrastructure and Tibor is gonna do a quick walk through the UI and various presentation views. And then we're gonna dive into the usability examples. I'll cover some of the technology, platform comparisons, and Radko will go into anomalies. This slide change, right? So we have two core projects within the FDIO, that's VPP and CSIT. I'm sure folks who have been to the previous talk and the talk before are hopefully familiar with what VPP is, a feature-rich networking and host stack software, user space, fast, runs on all sorts of cost hardware. We list here some of the platforms. A number of those platforms we actually have in the CSIT lab, so we'll be looking at the results there. So that's Intel Xeon, Intel Atom. We have a number of ARM platforms and also AMD. It runs on bare metal VM containers. We test all three, and generally, it's VPP is all about efficiency. From the CSIT perspective, our focus is on the integration and testing. That's where the name comes from. But we're really spending most of the time on benchmarking throughput and latency of VPP, and we also benchmark DPDK, as we do rely on DPDK drivers. And as we are using T-Rex, the traffic generator, we also run tests on those. And we run a lot of those tests. Peter will cover more of the breakdown in terms of stats and data that we need to process. Now, as of this release, which we currently have in progress, 2306, we are moving away from the static HTML pages to present the results, but moving to the dynamic dashboard, and that we are using for release results reporting, test results reporting, trending, and as you will also see, reporting on some anomaly detection and reporting telemetry. So, and that's really the focus of this talk. If you're interested in more detail about CSIT, please join our meetings. We also did give a talk at the LFN Development Test Forum last year, where we went deeper into detail about what CSIT is and what it does. So hopefully this makes sense. I'm going to now hand over to Peter, who will cover the infrastructure behind the CSIT dashboard. Peter?
Hello, thank you. So let's take a look on how we are processing the results from our performance testing. Jenkins acts as our primary executor of CI/CD pipelines. Each Jenkins job is producing a set of tiny JSON files. There is actually one JSON file per each test case, and that is defined by model. So we are strictly following a model that we defined. JSON contains the results as well as some metadata to the actual test, including the telemetry. We are collecting created JSONs and uploading them into S3 object storage. Currently, all buckets are hosted by AWS. Of course, we are supporting also the direct storage, although this feature is currently not heavily used at all. Our custom designed ETL pipelines are running periodically on top of the S3 storage and crawling new data on daily basis. The intermediate file format is Apache Parquet, and this basically offers us then speed and compression needed for storing large amount of data. We have chosen AWS Elastic Beanstalk as a main orchestration service to run our web application. As a web application, we are running Plotly Dash, and that's basically our main plotting engine. CSIT is then loading those Parquet files into the memory, only those that are as of interest, and delivering some application logic and basically displaying those data into form that you will later see. The whole infrastructure is scalable, and we will see the scalability on the next slide. So can you please move to the next slide? Right. So as of today, we are running 17 ETL pipelines. This includes our processing our training results, as well as our release results. Those ETL pipelines I mentioned are converting JSON defined by model to the Parquet, which is intermediate format, and then loading into the memory. Just to illustrate a picture, we are running about 2.9K tests per day, daily, and that's about 17,500 tests weekly. For the picture, for the release, we need to basically draw all the results, about 50K performance tests. Our good practice is to display at least 2 past releases, so you can just have a quick view on how many data we are processing every day, every release. And as of today, we are running data and those processing pipelines from 2021 up till now, and displaying just a very small subset of 130 days, which is sliding window where we are basically showing those results. And you will see how we are displaying those results, and that's handing over to Tibor. So next slide.
Thank you, Peter. Our presentation layer named CSIT Dash provides customizable views on performance data. We can split it into 2 groups. The first one is performance trending, which displays data collected on daily basis. The other one presents data coming from release testing. In addition, we publish also information and statistics about test jobs, failures, and anomalies, and the CC documentation. As you can see in this picture, the screen of CC Dash is divided into 2 parts. On the left side, there is the control panel, which makes possible to select required information. The right side then displays the user-selected data in graphs or tables. Performance trending shows measured averages of MRR values, NDR and PDR values, user-selected telemetry metrics, group average values, and detected anomalies. The data is collected on daily basis, as Peter said, using MRR tests, and weekly by NDR PDR tests, which are more time consuming. In addition, the graphs show dynamic labels while hovering over the graph data points. By clicking on the data samples, the user gets detailed information, and for latency graphs also a high dynamic range histogram of measured latency. Next slide, please. Per release performance section presents the graphs based on the results obtained from the release test jobs. So currently for 2306 release. In order to verify benchmark results, CC performance tests are executed multiple times on each physical testbed type. Box and whiskers plots are used to display variations in measured throughput, and for PDR tests also the latency values. Again, by clicking on data samples on the box, the user gets detailed information, and for latency graphs, also HDR histogram of measured latencies. Comparison tables provide a relative comparison of packet throughput and latency between user-selected releases, testbeds, NICs, and so on. User can select any parameter. There are listed mean values and standard deviations in the generated tables. CC- provides also detailed result tables generated from release test job executions. The coverage tests include also tests which are not run in iterative performance builds, so we have much more coverage tests than iterative tests. The tables present NDR and PDR packet throughput both in packets per second and bits per second, and latency percentiles at different packet rate load levels. Next slide, please. We also publish the elementary statistical data, which include number of passed and failed tests and the build duration of all daily and weekly trending performance jobs. Also, these graphs show dynamic labels while hovering over the graph data points with detailed information. By clicking on the graph, user gets the job summary with the list of failed tests. The failures and anomaly section lists last build summary, failed test progression, regressions, and for all daily and weekly trending performance jobs. The last but not the least part is the documentation. It describes the methodology, infrastructure, and release notes for each CSIT release. Thank you. Next page, please.
All right. Thanks, Tibor and Peter. So we covered now the sort of quick overview of the infrastructure and the UI and the presentation layer. So let me take you through the testing areas that we are executing, that are being executed within the FDIO CSIT. In terms of the networking data plane tests we run, and we've been running them for a few years now, we're covering L2, IPv4, IPv6, IPsec, WireGuard. We also cover the SRv6 routing in various combinations. We test some basic features of data plane like ACLs and policers, some stateful features like NAT44, and then today 3 types of tunnels: GTPU for mobility, VXLAN, and Geneve. We also test the VPP's vhost user and MEMF interfaces. And in terms of the drivers we use DPTK drivers for Intel and Mellanox NICs. We use VPP native drivers, AVF, for Intel NICs, and VPP native RDMA drivers for Mellanox NICs. And we also have now the AFXDP implementation to interact with Linux kernel and the NICs. In terms of test methodologies, people already covered throughput, latency, NAT44, host stack, TCP/IP, quick, and we test at 1 core, 2 core, and 4 core configurations predominantly. Now, in terms of test topologies, we have 2 main test topologies: physical topologies, 2-node and 3-node. We need 3-node for encapsulation and network data plane encapsulations that T-Rex doesn't support, and also for crypto. So IPsec, WireGuard, and GTPU are tested in a 3-node. From memory, I believe we actually managed to get the VXLAN test running on 2-node too. Now, in terms of different testbeds, so on the right-hand side, you see a few mnemonics with the code names for processors: CLX, ICX, SPR. These are the Xeon Intel processors, and ThunderX2, it's ARM, Zen2, that's AMD, and so on. I do have a breakdown on the next slide in detail, so we'll cover that there. But just on this slide, if you look at number of tests and test topologies and the performance testbeds variants. You can see that we've got quite a few combinations, and based on the infrastructure that Peter and Tibor presented, we are able to execute those tests automatically, and we believe that we are the only project that has a fully automated open source networking data plane benchmarking as a platform done out there. I think the PDK project is catching up and following our footsteps, but we're quite proud with what the project achieved. So this is a quick list of platforms and processor families we test. As I mentioned, Intel Xeons, Cascade Lake, Ice Lake, Sapphire Rapids, AMD EPYC Zen 2. From the and then from Intel also Atom Norwich at the bottom SNR. From the ARM ecosystem, we have the Cavium Thunder X2 and Huawei Taishan, and we also have the Ampere Ultra N1 as of last year. So we've got quite a selection. You can see some of the the model numbers, parameters, and so on, and also number of test beds. We also test different NICs. Originally, we started with 10 gig only, and then we cycled through various generations. Right now, we are starting to standardize on the 100 gig, and we have two types of 100 gig NICs. In fact, three: Intel E810, codename Columbiaville, 2-port 100 gig, and Mellanox CX5, 2-port 100 gig, and now we just added CX6, or adding CX6. 2-port, it should be 2-port 100 gig, typo. And we also received a donation from NVIDIA of the 2-port 200 gig NICs, CX7 PCI Gen 5, which we have running already in Sapphire Rapids. So now we're going to move into some of the stuff, the usability things, and what we can actually get out of the CSIT performance dashboard. Here I show a screen capture of the comparison testing in a VPP release 2302, Ice Lake versus Cascade Lake. The tests listed here in the top part are IPv4, and you can see the mean measured MPPS numbers for 64-byte frames measured for the Cascade Lake. That's the CLX circle or eclipse or a highlight, and then in the middle this is Ice Lake, and we basically calculate the relative change between in this case between those two platforms. So you can see that there is about 5 to 17% improvement when moving from CLX to ICX based on the testing done in the platforms we have here. Now, for IPv6, similar numbers. If I now try to do a little experiment and see if that works. So I actually have those views pre-canned, or because we can save URLs. So when you click on those links in the PDF that is already posted on the wiki page for this talk, you will be able to actually see the browser window that I have that I'm sharing on the right, and hopefully it's coming across okay if I share both, or do I need to blow it to the full screen size, or is this view okay? Can somebody confirm?
It's okay for me.
All right, I'll go with that. Cool. So that will allow me to move quickly between the views. So you can see that this is exactly the same view, and with Folk's genius, specifically big thanks to Tibor, you can filter the results data based on text and regexp, and be specific in terms of what exactly you want to see. So the results can be manipulated. Data can be downloaded in a CSV format and also can be saved. Now we have the just published results from 2306 RC1 that Tibor has already alluded to and showed some screenshots from. So just click on that link, and again, if you look at the results, okay, it looks like we don't have an IPv6 there, but if I look at IP4 scale, you can see the the differences in performance for that specific release. We can also use the comparison tables to compare between the releases. So, for example, we can choose the same testbed that I've chosen above, and just use the previous release. And the calculation is immediate, and we can have IP6 scale. Looks like we don't have an IP6 scale, so let me just see what I can have. IP4 and IP4 scale. Looks like we didn't test IP6 yet in RC1.
We did, but the packet size is different.
You see. So here we go. A user error. I'm usually getting too excited with those things. Okay. Now I need to. So in fact, I should be doing the reference should be 2302 islake testbed with the right bucket sizes. Thank you, Bratko. And I can now compare to the latest release from RC1, and I can now see the actual performance numbers, and it looks like performance is down based on RC1. So that is something that we usually look at as part of the anomaly detection and investigations. So that's one way to interact with a dashboard. So this is performance, throughput, and stuff. Now, what we have also added in the performance dashboard is ability to show VPP per node metrics and statistics that are collected in CSIT performance tests. I guess a lot of people familiar with PPP are aware of the by now famous show runtime, which provides the per node statistics like number of calls per node, clocks per packet, and so on. So we've been collecting this for a while, and now we have a quite a nice way to display it, and I'll demonstrate it in a moment. In terms of trending and comparisons, we also quite some time ago, a few of the VPP core developers from VPP Dev, Damian and Ray and a few others, added the functionality called VPP Perfmon, which allows VPP to read the PMC counters on a per node basis. It's an invasive measurement, so show runtime can be run in production. VPP Perfmon should not be run in production, and it's more of the developer tool. So, and that's why there is a note at the bottom of the slide to proceed with caution, because developers know how PMU counters work on each of the platforms, and which ones are correct, which ones are not always correct, and any dependencies between those PMU counters. But nevertheless, we decided to run it here just out of interest, curiosity, and see if what we expect to see we actually see. And here we have a bit more information. We have clocks per packet. We also have cache hits and misses, and I will show some screens with those two. Right now we have it running on Xeon platforms on Intel. ARM, although the code is there, we need to run a newer kernel, so this is a work in progress. And Yeah, so just a note of caution again, Perfmon is really a developer tool, and to interpret the results, and for example, to distinguish between a good or bad code, you can't rely on those counters. You need to read the code, but the counters are indicative on for example, for different scale configurations, on whether what we expect to see in terms of, for example, cache hits and misses, whether we do see. So a quick note on how those metrics can be selected. I'm not going to go through the full flow due to time, but basically there is a new Add Telemetry panel button on the control side, on the control panel side, or side of the screen, as Tibor explained, and that's where you basically type the metrics or select them, and you construct your views. And that's the way I constructed the views that I'm going to share on the next screen. So let me do the same trick again. Now it does take time to build those views. So I have them pre-canned, but you will see that they do resolve. It's just they're processing quite a lot of data. The URL saves the user selection state. So on this screen, I'm showing one specific test, which is the IPv4 scale test with 200K/32 prefixes, which are randomly stimulated or hit by the traffic generator. And I'm showing this for 3 platforms, for Cascade Lake, Ice Lake, and Sapphire Rapids. And I'm normalizing the frequency for comparison to 2 gigahertz. So those testbeds operate at their base frequency for each of the chips. They are slightly different. So this comparison is actually normalizing it. So the results here between at the top, SPR is the fastest. So it's about 22 Mbps. Ice Lake is the next. It's about 18. And you see this trend line averaging about 18. And then the slowest is a Cascade Lake. So there is about 20% difference between Sapphire Rapids and Ice Lake, and 20% difference between Ice Lake and Cascade Lake. Now, this view is our trending view. The tests are running daily, and the beauty of this new platform that the CSIT does is that the moment the tests are done and the results are recorded, you can browse them in here. So we can quickly see if there are any issues, anomalies, but also you can see the consistency of performance. Now with telemetry, we can now have a sneak peek into why there's a difference in performance, right? And which node is responsible for it. So I have selected here the IPv4 lookup node, which is the one doing most work when we're scaling up the FIB table. And you can see that there is this difference of 20% in end performance is reflected pretty much in the cycles per packet. So on the SPR platform, it's about 60 cycles. Here is about 70, and Cascade Lake is about 80. And these are the show runtime counters. So something that VPP developers and testers are familiar with. Now, for comparison, I have added the view with the Perfmon bundle, and you can see the shape of the graph and the values are very much aligned. So Perfmon is reporting similar numbers than as a show runtime. So I'm just watching time. You can see that the same view that I clicked has rendered, and it does take time to go through the data. The team is working on caching options, so we're expecting the performance of this to improve. So IP6 scale is very much a similar view. I think I have it open here. Again, Sapphire Rapids is the fastest, followed by Ice Lake and Cascade Lake, and we expect, again, the differences are at the level of 15 to 20%. We did when we put in production. We get into this question quite often. When we added SPR in production, there were various, new knobs that we were not familiar with, the clock frequency was set, and it wasn't actually keeping it at the base. It was turbo, so that's why you see this drop here and the anomaly detection. So this results before this drop can be simply ignored. Okay, so what I'm gonna do now, I'm gonna move to somewhere where I actually want to look at the FIB scale. So at the top link, oops, sorry, wrong button. If I click the top link, I get another spinning wheel. So let me just go to the my precant option and find it. Okay, so this is where I'm showing the performance of VPP of master branch or main branch source code tested up until 6th of June, and the fastest performance at 16 million PPS or so. I have it for the baseline test, so without really loading the table, and then it drops down through 20 and 200 and 2 million. And again, the cost of processing the packets is reflected in the nodes. So to process the packets at the large scale, 2 million IPv6/128 routes hit randomly takes about 390 cycles, compared to when the table is shallow at 75. And so this is expected. And one of the reasons for that is, which is a bit of the indicative thing. I said, be careful with the telemetry results for things like cache hits. But one can see that on a per packet basis, we do have, for the larger scale, 2 cache misses, LOC cache misses on the per packet basis. So the data structures have to be looked up in the memory. And that's one of the reasons that may explain somewhat the difference in performance. So it's just one possible cause. Okay, now just watching time. So we can come back to those views if we have time towards the end, but I'm gonna give the floor to Radko now. Radko?
Yeah, I was checking my browser, and then I basically mute button. My plan for this talk is to show you more interactively how I interact with our new user interface. So this slide is just, well, mostly a placeholder, or for people who do not watch the video from the presentation. The links should be clickable, and they will show you one of the state I will be showing you. But what I want to focus on is not just one graph, but the whole process of how I interact with it. And yeah, so I think I will start sharing my browser.
So I'm going to stop sharing and you are sharing. Okay.
When I find the button. Yeah, so now let's see it. Okay. Okay. So this is the gateway, or how do you call it? This is our URL. You can access it, and I will be talking about not everything, just a few of those. Okay, so what was my start? So one is this the job statistics. When I open it, okay, so this I can move it here. Okay, This is statistics about job. You have already seen a slide commented by Tibor. I was trying to focus on some things that are happening. This is one interesting region where the user interface is reporting the number of tests that we were running was lower than usual. Sometimes it is expected. Here we were running almost 500 test cases in a single run. Here we are running only 300. That's intended because we knew that the run is already taking almost 12 hours. We want to have more space to add more tests in the future. So we decided to reduce the number of tests that is expected. Also, this gap in between, some of those gaps are expected. For example, when we are doing a lot of runs for release, we are not focusing on trending. So that's why there is a low density of runs here. I think what was happening here was some infrastructure issue. We were not getting the results that was known, but this was something that was not known. And this turned out to be, once again, infrastructure preparation for test, and the robot framework, when it tries to initialize a suit and the initialization fails, it will simply skip all the test cases that should be running. So this is pointing at some error that needs to be fixed. And so this is one additional use. So not only red color like here, but also white color there. So that is one example. And another example, I want to open this values and anomalies. Okay, I have prepared this, so I do not need to look at it. So this is one particular job. When you click it, you see, okay, it is running, and some test cases are failing. And when you use this view and you switch to the job, you see, okay, there are only 8 tests, but everything is failing. So this is a bigger issue than just a few tests running. We need to investigate this. I think this is another infrastructure issue. That's why we were not able to fix it quickly, but known issue, and we know what is going on. So that's about statistics. How many minutes do I have? Okay, I have so in this presentation, I just went through here and here. These 3 examples will take me longer because I will be interacting heavier. I will probably not have enough time to show you the third one, but I hope I can show you the first 2 ones. So once again, I want to start with these values and anomalies. Now I need to look at all the runs because I will be showing you an older issue, not this one. Oh, why my copy and paste is not working? Okay, this one. So this is bigger job, and you see just one failure, but many regressions. This is regressions, and to find the one regression I want to focus on, I have to jump all the way here. And why I want to focus on this, because this is quite a simple test. We call it a baseline. So this is like very simple smoke check. This should be working. There is no good reason why there should be regression unless something is happening. This is, well, we have upgraded. We are now moving to this network interface card as our new default, but this was the old default, so this should be stable. AVF driver is also working fine, so this is surprising. In a later show, I will show you why some of those failures are not as surprising. Like, basically, there is still some amount of noise. Not every regression is real, but this, you know, this test, this should be stable, and it is not. So how to deal with it. We can jump through here to performance trending and start looking at the job. So which one it is? I already forgot. It's okay. Ice Lake. And okay, so let's start filling its VPP. Promote Ice Lake, this one, and the test case is this one. The default, just one core, MRR because that's daily, and yeah, this is it. So it has decreased, let's say 1%, so not a huge deal, but as you see, the performance was, let's say, consistent enough before, and now it is consistent enough later, and it is clear that something has changed. Maybe we have done something to the testbeds as we add new NICs, and as VPP changes the drivers, sometimes we need to upgrade the firmware. So maybe this is one case, but yeah, usually I'm the one guy that should look at these results and start investigating what is going on. So how can I investigate what is going on? So first of all, this is a AVF driver, and maybe this is something specific to AVF driver. So what can I do is change the AVF driver, use DPDK plugins. Say same test, which is cross connect, same default value. And when I add this graph, I see, oh, what a surprise. There is this new test, and it has progression instead of regression. So definitely something interesting. By the way, the color scheme is always the same. The user interface sorts the test cases alphabetically, and the first one is always black, the second one is always red. Now I see that we probably stopped testing this test case to save runtime for another test cases. So this is, as I said, this was the old default NIC. Now we are using new default NIC. So if I'm interested in newer values, I can just switch to the new default NIC, which is still looking at DPDK, and it is this 100. By the way, you do not need to track every little detail technical I'm talking about. This is just to show you how responsive the user interface is. So, okay, we see that the two performances were quite close to each other. DPDK doesn't really matter which NIC is used. The fact that DPDK plugin has smaller performance than AVF is expected, so this is fine. So, complete the picture, we can also add this new NIC with AVF driver. And when we do that, we see that, oh, so this was probably the reason why there was a change on VPP side. I guess some developer was optimizing AVF driver, getting a nice big performance boost for this particular case, but for some reason affecting the other ones. Okay, now I know that this is probably a VPP code change, or, well, you cannot be sure just by looking at the details, but you can form opinions. Okay, this is too high. I want to focus back on these guys because there is a regression, so I will remove this one. And what can I look? Back when I was preparing this change, it was not as clear. Now, for me, this is a very big clue, because this looks like bad performance, and single run has high performance and at a similar level as before. I can click on the detail so I can highlight. Usually I am looking at this number. This, as Maciek told you, we have multiple copies of the same setup, so we can use it more efficiently. And to avoid any hard-coded translation, we are just reporting the raw data as seen. So the test was seeing this IP4 addresses. So this is my identifier for the which testbed is using it. You can see that in the last line of the hover information. So this is 86. The other ones are 84. And these ones, okay, so these are 88, strange. And there is 82. And this one is 84. So, okay, I can confirm, but they are coming from the same run, so they should have the same numbers. These tests were executed in the same run. I can remove the red one to focus back here. And yeah, so this is my clue. This one means 84 with better performance. This one means 84 with worse performance. So even if there are some differences between testbeds, apparently 86 is better than 84, this still means that there was something happening on the VPP code, or maybe some firmware upgrade or something else. So this is my information. I can, when I will be bisecting for the real cause, which VPP commit may have changed the difference, I have to be sure that I am restricting myself to just this testbed. And yeah, I think one more thing, when I have the view that I'm satisfied, I can just click here, triple click, Control C, Control V to confirm, and I can post it to our chat so other people see what I'm looking at. So this was one example. And do I have time for another example?
Maybe, it depends on how long it's going to take. We have 10 minutes left to finish, and wanted to give some time for discussion and Q&A.
Yeah, maybe so we can like postpone. If there are questions, we will be reacting to questions. If there are no questions, we can go back and show another example. So I will stop sharing.
Sounds good. Thanks, Radko. All right. So hopefully you can see the slide with some of the scenarios that Radko covered.
Yep.
And that was pretty much it from our side. Here is a list of some of the resources and online references that have been produced on the back of the work done in CSIT directly or indirectly. There are a number of technical papers coming from Intel with some contributors from the CSIT team, and some of the video clips, showing how with VPP we are able to achieve terabit per second levels of speed, clear text, and also IPsec, and some of the links to the presentations and the video materials. In terms of the community, the landing page, wiki page is at the top, and there are details about our meetings. We are meeting every Wednesday. We are very friendly and open community, so please join us. You can also interact with us using the CSIT-dev mailer at lists.fda.io. And there are some other resources, and including where the source code is. We also have some of the PyPy libraries, specifically for the code that Radko's been leading, the MLR search for rate discovery, and also jump average for anomaly detection. So with that, we are done with what we have prepared. So let's see if we have any questions, comments, interactions, and if not, then Radko can go into some of the other use cases.
So one of the things that I found challenging, and I was trying to find, I had opened a Jira ticket to help drive the discussion on this, and I know there's been a whole lot of work that's been put into the UI here and how we filter the data and present it. One of the things I find challenging is if I just wanted to go find like the host stack tests results. I think it would be helpful if there were either a search or a category type of filter at the top level that would let me figure out, you know, what test beds it run. I mean, I kind of from this, you kind of have to know where the test runs in order to find the results. And I kind of think that most people are going to look at it from, oh, I'm interested in this protocol and what results are available. So anyways, that would be one suggestion I would make, that we try to figure out a way to either tabulate, you know, either links or whatever. Maybe there's a different page that we set up, since you can, you know, you can save the URLs to specific test results. Maybe that's the only, maybe we just add that to the wiki, and that would be a help. But
that could be a very quick fix, because you're right. We're not running co-stack tests on every test bed. It's only a subset. So you need to know which one to choose. A quick fix would be indeed to have a saved URL with just this selection, and then let people interact from there. But yeah, let's see how we can accommodate that in terms of the flow.
Is there anybody on this call that is interested in the kind of static format of the, you know, so we made change from static data to dynamic data. How else, other than developers? I mean, I tend to look at it more from a developer, from either marketing or research. Is there anybody else that has an interest in more of the old style canned data? Is there, you know, are there any other thoughts on how one might want to consume this data? Oh, okay, because we don't have marketing folks on it. Just curious to see whether we have a strong need for some way to package, you know, either in a presentation or a PDF or whatever. I mean, you can always print screens, I guess, or do screen captures. Have you had any feedback, Maciek, from anybody on
No,
that?
people actually do prefer the dynamic data and go with the screen captures. Not all of the views are, you know, beautiful to go straight into the marketing presentation, but data is downloadable, so per constructed view, so that you can get it into the spreadsheet and then do the bars, tabs, circles, pies, or whatever you fancy, right? So I think from that perspective, we are okay. I think the usability and number of clicks to get access to the data you're interested in is, I think, what we are looking for. So any feedback on, you know, what information is of interest and what are the usability scenarios? So Dave, you gave a good example of that. So I think we just need to. It's a new platform, so we're waiting for feedback from people who actually use it, and then we will be making adjustments as we go along.
Excellent. Well, thank you for the work that you've done. This is really impressive.
Well, kudos really goes to the team.
Any other questions, or should we've got 4 minutes left. Bradko, can you use 4 minutes, or should we give people the time back?
It's actually 3 minutes now.
I think I will use like 1 minute.
All right, we'll go for it.
Yeah, so I mentioned it already that sometimes the progressions and regressions are not real, and this is one example. This is not the fact that VPP performance is jumping wildly. This is another issue. We are using the new NIC and with a DPDK driver, For previous generation, it was using the static or constant, or how do you call it, RSS behavior. So this is that's when we have 4 IPsec tunnels, and with a deterministic RSS, the traffic comes and it is divided between workers in the same way. This is one physical core, and we have enabled hyperthreading, so there are 2 VPP workers. And what you see here is the driver for E810 no longer has RSS deterministic by default. For security reasons, every time you initialize the plugin, the random key is generated, and these differences this is good division of work between the workers. This is worse. I mean, one of the workers is doing, for example, decryption for everything, and this is even worse, that one worker is doing both decryption and encryption. And in this situation, our anomaly detection basically cannot know what is going on, and it just does what it can. So it decides this is high standard deviation, and this is stable, and this is one outlier, and this is once again stable. And so for this reason, surprisingly large amount of regressions and progressions is not real. It is just an artifact of the behavior of the system. We are, of course, trying to fix every issue that we see. We are very strict on how the VPP is configured, what the BIOS configuration is, and so on and so on. But things like that are still there. There are still few systems and test cases that behave in this inconsistent way, and we are investigating why. And that's all for me. I will stop sharing.
All right. Well, thanks everyone for joining us today. Excellent presentation. Thank you to all the presenters who went through all of the new CSIT dashboard features, functionality, and architecture. And have a great rest of the day and the end of this June 2023 DTNF.
Excellent. Thanks so much, Dave, and everyone. Appreciate your time and attention. Thank you.